We begin Unit 13, Radicals and Rational Exponents, with simplifying other roots. There are roots other than square roots. The small number on the root symbol is the index. It tells us which type of root it is. When simplifying any root, the type of root tells you how many form a group to go out of the radical. Note square roots are understood to be an index of 2. We don't write the little 2 down. So let's simplify the fifth root of 64. 64, we can break that down in our prime factor tree to be 8 and 8. 8 breaks down to be 2 times 2 times 2, and we have that twice. The index is 5. That tells me that I need to pull out a group of 5 2's. Those 5 2's become 1 2 out front of the radical. What's left over stays underneath the radical. So the answer is 2 times the fifth root of 2. Let's look at another example. Let's break down 32 in a prime factorization tree. 32 breaks down to be 4 times 8. 4 breaks down to be 2 times 2. And the 8 breaks down to be 2 times 2 times 2. Let's break down the x's. There are 6 x's in x to the 6th power. Let's look at our index. In this problem, our index is 4. This tells me that I'm going to look for a group of 4. So I need to see if I could pull out 4 2's and 4 x's. I do have a group of 4 2's, so that will come out front of the radical. I also have a group of 4 x's. That will also come out of the radical. What's left over stays underneath, and we multiply that all back together. Do not forget to put your index in your answer. And this will give us 2x times the fourth root of 2x squared. A handy trick to remember for variables is I can divide the index into the power underneath the radical. 4 goes into 6 one time, so I pull out 1x. There are 2 x's left over, so they stay inside the radical. Let's look at another example. The index in example 3 is a 3. This tells me that I'm looking for a group of 3 to pull out. So when we break down 64, we get 8 times 8, and 8 times 8 is 2 times 2 times 2 times 2 times 2 times 2. And underneath the 2's, we have 6 A's and 7 B's. Let's group our numbers and variables into groups of 3. I have 2 groups of 2, so that would be 2 times 2. We also have 2 groups of A, so that would be A times A. Remember, we pull out one variable for each triple, and we pull out one number for each triple. And when we group the B's in triples, I have 2 groups of B's. So let's pull out 2 B's. Now since there's a negative sign out front, the cube root of a negative will always be negative. 2 times 2 is 4, so this is going to be negative 4. A times A is A squared. B times B is B squared. And underneath the radical, all we have left is this lone little b here. So I will have the cube root of b. So the answer is negative 4 times a squared times b squared times the cube root of b. Now let's look at the fifth root of negative 32. Let's look at our index first. The index tells us that I will pull out groups of 5. The negative out front will just come out front of the radical, because if I take an odd number of negative signs and multiply them together, I still get a negative. So the fifth root, the third root, the seventh root, all the odds, the negative signs will come out front. Let's break down 32. 32 breaks down to be 4 times 8. And 4 breaks down to be 2 times 2, and 8 breaks down to be 2 times 2 times 2. There are 5 x's and 10 y's. Let's start with the 2's. I have 5 2's, so I will pull out one of those right here in the front. Let's look at our x's. There are 5 x's, so I'm going to also pull out an x out front. And notice there are 2 groups of 5 in the y's, so this is y squared. Also remember that you can divide the index into the power underneath the radical. 5 goes into 5 one time, so I only pull out 1x. There's nothing left over, so nothing stays underneath the radical. For the y's, 5 goes into 10 2 times. Let's look at the next example. If the indexes are the same on the radicals in the numerator and the denominator, I can divide 48 by 2, and we get 24. So this is really the cube root of 24. Now this will be easier to break up. So 24 breaks down to be 8 times 3. And 8 breaks down to be 2 times 2 times 2. Our index is 3, so this tells me that I'm looking for groups of 3. Since I have 3 2's, I'm going to pull out a 2 in front. 3 is left over, so it will stay underneath the radical symbol. Do not forget to put your index. Now let's look at number 6. Notice 8 will not go in the 27 evenly, so the trick I used with 5 does not work. However, I noticed something interesting. If you remember from square roots, or simplifying square roots, that I can also break these apart. Now I'm looking for groups of 3, because the index is 3. But I noticed that the cube root of 27 is 3. And the cube root of 8 is 2. Now let's look at 7 and 8. Remember from simplifying square roots, I cannot combine 2 square roots unless they have the same or like radicals. Well, that's the same with other radicals as well. I have to have the same index, and I have to have the same number underneath in order to combine. So this means I need to simplify these radicals, because 80 and 5 are not the same. These both have the same index, but I can't combine them because the number in the first term underneath the radical is an 80, and the number underneath the second term radical is a 5. Let's simplify 80. When we simplify 80, we get 5 times 2 times 2 times 2 times 2. The index is a 4, So that tells me I'm looking for a group of 4. I have 4 2's, so I'm going to pull out 2 in the front. Remember, anything that we pull out gets multiplied to the number that's already out there. So this is going to be 2 times 12. What's left over stays underneath the radical symbol. So 2 times 12 is 24. So we have 24 times the 4th root of 5. Now I notice something nice. Now the numbers underneath are both a 5. Since they're both a 5, I just combine the coefficients in front. These are the same sign, so I'm going to add 24 and 18 together. 24 and 18 is 42, and that's multiplied to the 4th root of 5. You try the last example. How did you do? You should have gotten 10 times the square root of 2 plus 11 times the square root of 5. Notice the index is a 2 because it's understood to be a 2. So we're looking for pairs in each of our terms. So in the first term I'm able to pull out a 5, and remember we multiply the 5 times the 2 to get 10 times the square root of 2. In the second term I pull out 2 2's, and we multiply anything we pull out front together. So 2 times 2 is 4 times the square root of 5. In the last term we pull out a 5. Remember we multiplied that to the front, so 3 times 5 is 15. Now I can't combine the 2 and the 5's together, but notice that I do have 2 square roots of 5. And 15 minus 4 is 11. So the answer is 10 times the square root of 2 plus 11 times the square root of 5.